Hello, my name is Lincoln Shear, and I'm here just to give you a little rundown of the calibration version number 3 script. And the script is for the CO2 Flux project at Fort Lewis College. So it loads and processes data from ELT sensors and a reference sensor, then applies calibration modeling to that by training neural networks, linear models, piecewise linear models, and then kernel regression models. It evaluates those models and the performance of them just on some test data sets, generates plots showing for some visual inspection of that data, and then it saves the data and models for future use. It takes about 5 to 10 minutes to run this. So first we're gonna just take a peek at the initialization parameters here. This you can ignore this initialization section here, but let's go down to configuration. There's a struct config that just holds all the parameters required. This data import section is pretty important. So this will, you can label data sets ambient, closed loop, or both. Ambient indicates that's about ambient CO2 ranges. Closed loop indicates that it's enhanced above ambient. So this is going to be like plus or minus or plus 500 ppm here. This is going to be about 4 to 500 ppm here. And both just includes both the data sets. We've got a smoothing window in minutes, a retime duration in minutes. These generally should be the same. We've got the possibility to remove some outliers in the top and bottom percentile. We're just going to ignore that here because that's not really useful for calibrating for the variation of our own sensors. And then a reference min and max. So this is going to be the range that we're calibrating against for our CO2 sensors based on the reference. And these are in ppms here. This is about the model training parameters. So we can choose to replicate data by binning it and then having a number of bins per or a number of counts per bin. So just to ensure that we've got a good distribution of data set. We've got this section here, which is a k-fold holdout, which is the amount of data the percent of data that we're using to train, validate, and then finally evaluate the models on. You can play around with this here. Predictors, right now we've just got CO2, temperature, and humidity predicting to a target variable of the reference CO2 here. This is a little section here that talks about the neural network training, the neural network that we're going to create here. So these are the number of hidden layers here, maximum number of epochs that we'll try to use, and then our kind of stopping criteria for our minimum target root mean squared error. And this is going to be in ppm here. And so yeah, once we're done, we're all good to run here. And so it takes into CSV files, test periods, which is just a little CSV file that just has the data that we're using, the range of dates that we're using from this data set, and then whether it's ambient, closed loop, or both. And then the sensors that we're calibrating, we're just using some dummy sensors here, A and B. And then we've also got train periods here, which is going to be a separate file. That's going to be all the stuff we're training against. I'm sorry, I think I got messed up. Test is going to be what we're testing and evaluating. Train is going to be what we're training on. And so these are the two data blocks that we're using to train the models. Test is going to be what we're evaluating on to get the actual results on. And so, let's go. Click run. It's going to take a little while to import all of the data here. So once that's done, we'll just skip through that. All right, awesome. So once that loading has taken, it took about 200 seconds here to complete, and we're now ready to go on with the rest of the script. So I set a little breakpoint right after this initialization and import training data section, just so that we could catch the script and not have it blow through everything. But let's just go ahead and continue now. So it's going to plot all the raw data, and you're going to see a bunch of figures that just pop up as it just talks about the data that we've imported. this is going to be, the amount of hours of data that we're actually training everything on here for each sensors, for the models that we're creating. And then it's going to start modeling each of the sensors by just creating the models. And so this will go somewhat quickly. We have a little progress bar that prints out across the screen, just as this updates throughout. And again, all throughout this process, you're going to see just plots popping up on your computer. You most likely won't be able to use other applications while running this script, but luckily it only takes a couple of minutes. So yeah, we're done with modeling A, now modeling number B, or sensor B. And then if we look at the outline of the document, after training models is completed, which we're on right now, we're going to just create some plots, just displaying that model overall comparison. We export those models, save them so that we can use them later. And then we pretty much repeat a lot of this beginning process where we locate some new test data, we import that test data, we do all the pre-processing that we did on the training data just so that we're comparing apples to apples, and then we apply our models that we just created on that test data, and then we just plot all of that, save that to this folder over here, figs_training, which just will have a ton of plots here that we can loop back and just see what was created at each step. And so yeah, once all of the model generation has completed here, we can look at our overall model comparison. So we have three tables that are shown, the models that were created for sensor A here, each of the model types with their predictors, root mean squared error, and R² value. And then same with sensor B here. And then we also have another plot that just compares all of the models across any sensor, and it ranks them based on the lowest root mean squared error, which is just really important for us, because root mean squared error is pretty much the overall error of the sensors that we're using. And so yeah, all of this import test data, it's going to take a while. It's going to do the same thing. And so I'll pause here and then circle back once we're done. All right, awesome. So it looks like all of that data has been loaded in. I didn't set a breakpoint this time, so I just hit pause when I saw it had passed through. But so it's going to, fill out that progress bar 100%. It'll give you a little bit of time for how long that took. And then it'll just do the same pre-processing, which is really quick. It'll apply all of the models to the test data, so let's just continue as it just rolls through here. This should be pretty quick because applying the models and instancing the neural models doesn't take a long time. And so you'll see again a bunch of plots pop up as it's just creating them and saving figures, and then it'll just finish up. We can see nothing's running anymore, and so we're all set. And then all of our calibration models that we've created are going to be in this models folder here. They will be organized by the sensor name, the model type, and then a date that they were created on. And then, so that's all that we've got here. And then it'll also show some of the original data that we used to train the models here. Will show the partition data, correlation versus lag. Will show if there's any time stamp shifts. These three files are just the ones that we imported to train and test the data on. So they're all going to be just plotted so that we can see what's going into the models. These are all of the previous calibration models that we had applied. Raw data overlap just shows the data overlap that was used to train. Some one-to-one plots showing the performance of all of the models across the different models that we trained. And then, just a bunch of useful plots here. And Awesome. So now we're all ready to party and apply some of these Flux, calibration models that we just created to the actual data. So let's go and just double check where we are. We're still in the same dynamic calibration folder under ELT calibration and then our main repository here. So we're going to go to the script flux underscore v1.m, which is going to be a new version of this Flux calculation script that we can apply the models that were just created here. And it's going to follow all of the same mechanisms that calibration v3 uses to load in all the data. So we've got some just examples here. I'm using some data here from July 26th and 29th here to load in. And so it's just going to follow the same CSV style that the training data did. So we've just got a single file here. I wanted to include all of the data set, and I didn't really spend time looking into the actual file to see when I wanted to. I knew that the data would be definitely within these ranges of the 23rd to the 25th because it was taken 2024, so I just included that. The sensors that were mapped to that data set at that time, this is going to be the most important to make sure that the models that we are creating are applying to the correct data set. So anytime you're doing any sort of flux measurement, you're going to want to record which sensors were at which specific chamber locations so that they're recorded to the correct channels in the data stream. But yeah, so we're using A and B, the same dummy sensors that were used to train the calibration models a moment earlier. But yeah, the script is going to be relatively quick. Let's take a peek here at some of the configuration parameters. So just some physical constants: surface area of the flux chamber, the volume of the flux chamber, pressure in Durango, temperature in Durango. So we're just going to use room temperature here. Molecular weight, CO2 conversion, some constants from our data sheet from our flow sensor, and some data processing parameters, just like in the calibration script. These aren't as important for the outlier sections, but the smooth duration still applies. We really don't get into any of the model partitioning or doing any of the model training that we did in the last one, but keeping these variables here allows us to use the same functions and everything from the calibration script before. And then just some unit conversion functions. These should be correct, just converting ppm to milligrams, milligrams to ppm, liters per minute to cubic meters per second, etc. The flux uncertainty function is just a uncertainty propagation of the steady state flux mass balance equation here. And so we can just enter in change of CO2, surface area, uncertainty in a couple of variables, flow rate and CO2, actual flow rate here, which will read in from the data file. So yeah, let's just click run, see what happens here. Yeah, so it's just locating the test data. It'll import it. Takes really quick because they're not super huge multi-megabyte files like the training data. It will just generate a bunch of plots as we'd expect it to. It'll apply all of the different models that we created, the most recent ones, in fact. So those linear, piecewise linear, kernel, and neural network. So we're going to plot calibrated data for each of the sensors so we can see both of the flux chamber channels in a separate data set before the flux was calculated with them, and then we can also see the flux afterwards. So yeah, calculates the flux using all of the models just so that we have a nice variety we can choose from. And then it provides a summary in milligrams per meter squared per hour. So some of these models were really, really outdated. So we've got a lot of variation here. I'm using a dummy flux data set here, so we're not going to get necessarily things we'd expect, but you can see we get a minimum maximum flux value in that meter or milligrams per meter squared per hour. And then we get a mean for the entire data set here. This is just really nice so that instead of looking at the actual files, we can just get a sense of if there was something wrong in the script that's running. And then to see what was outputted, we go to figs_flux here.